How do we decide whether a triangle is a right triangle?
A squared equals A plus B squared.
Yeah, so the Pythagorean theorem, A squared plus B squared. We're going to see if it equals C squared. If it does, then it's a right triangle. If it does not, then it is not a right triangle. So which one of these sides would potentially be C? Yeah, square root of 57. So this one will be C. Make sure you're able to square radicals without a calculator. We're going to have 3 squared plus 7 squared and see if it equals the square root of 57 squared. 3 squared is 9. 7 squared is? The square root of 57 squared is 57. Because squaring and square rooting are opposites of each other. 9 plus 49 is? Does that equal 57? It does not, so we can say this is not, bless you, a right triangle. You are, however, equipped to know what kind of triangle it is.
It is a acute triangle.
It is acute. Because 57 is smaller, that's the hypotenuse squared. It is smaller than 58, so this would technically be acute.
Oh, wait a minute. So, wait, why is it acute again?
Because this is the hypotenuse squared.
Right.
It's less than the leg squared.
Okay, so
that
if
means
it was,
greater than, that's obtuse. And when it's equal, that's right. Number 8, we need to do the same thing. We're going to decide which one is the hypotenuse. So which one of these is the longest side? 5 square root of 5. Because if you type that in your calculator, it's about 11.1, I think. Whatever it is. It's more than 11, so this is the third side. This is C. So we're going to say 11 squared plus 2 squared will equal 5 square root of 5 squared. Make sure you have those parentheses so you know you're squaring the whole side. 11 squared is 121. 2 squared is 4. 5 square root of 5 squared. You're going to square the 5 and the square root of 5. You're going to square both. 5 squared is 25. What's happening between a number and a radical? They're being multiplied. Okay, so the square root of 5 squared is 5. 25 times 5 is 125. So all we did was square this. 121 plus 4 is? Does 125 equal 125? So then this is a right triangle. Ta-da. So these are the 3 trig functions. We call them trig functions or we call them trig ratios, either way. What did the S stand for? Sine. I'm just going to write sine. Sine was what side over what side of SOHCAHTOA? Opposite over hypotenuse. You can really write this however you want. If you want the word opposite to fill the whole blank, you just need to know opposite is in the numerator and hypotenuse is in the denominator. So sine is opposite over hypotenuse. C stands for cosine. So SOHCAH, this is the one that people spell wrong.
Miss Marshall, I apologize.
What goes in the numerator of cosine? Adjacent over hypotenuse. And then T stands for tangent, which is opposite over adjacent. So basically how this week is going to work out, we're going to do tangent today and tangent only. We're going to do sine and cosine tomorrow. They're all the same thing, but this is just to help you learn what you're doing and then think further through it. You will need a highlighter out. We're about to fill in the blanks down here. So the main problem that students find... All right, so the main question students have for me is when do you use the Pythagorean theorem and when do you use trig ratios? You only use the Pythagorean theorem for one thing. Can anybody tell me what it is? These are all right triangles. What is it? Yeah. To find a missing side. So what you're going to do, trigonometry is study of triangles. We talked about that. If a right triangle has a missing side, you use the Pythagorean theorem. So also a good way to know is you're given two sides, and you'll be asked to find the third side. So the Pythagorean theorem, you only use it for sides. Only use it for sides. You won't ever use it for angles, just sides, to find a missing side. That's the purpose of the Pythagorean theorem. You can also use it, yes, to find out if a triangle is a right triangle. But will you ever plug an angle into a squared plus b squared equals c squared? No, only a side length. Okay? So the next two things are when you use a trig ratio. So the first instance, which we're going to learn today, if a right triangle has only given you two sides, then you can find the missing angles using trig ratios. I know you're not going to study for science in this class, right? You just pulled that up because you were doing something. So if a right triangle has only given you two sides, you can find the missing angles using trig ratios. So sine, cosine, and tangent. Okay, so you decide that you want to interrupt my class. Get out of my classroom. Walk away. It's not funny. All right, the second thing. If a right triangle has only given you a side and an angle, you can find all missing sides and angles using trig ratios. And I'll show you what to highlight. Okay, so here's just going to highlight. So when to use the Pythagorean theorem, you have two sides, you're missing a third side. What you need to make sure you know is that you only plug in sides into the Pythagorean theorem. It will never help you find an angle, ever, ever, ever. Okay? So you're only going to use for sides for the Pythagorean theorem. Okay, so all you need to know is sides. Sides, sides, sides. That's the Pythagorean theorem. For the next part, if a right triangle has only given you two sides and you're finding a missing angle, you're going to use a trig ratio. So sine, cosine, or tangent. That's what a trig ratio is. You'll either use sine, cosine, or tangent. So whenever you're finding a missing angle and they gave you two sides, you're going to use a trig ratio, either sine, cosine, or tangent. And then last, if they have given you a side and angle, you can find all missing sides and angles using trig ratios. So if you're given a side and an angle, you're going to use trig ratios. Because again, can you plug in an angle into the Pythagorean theorem? You cannot. Only side lengths go in the Pythagorean theorem. Once you've got that, you can go ahead and flip to page 2. We're going to review what we did yesterday. You'll probably have to copy off of Nate when we're done. Okay, so we're going to practice from yesterday. It says find all the trig functions from the smallest acute angle. It'll either say trig function or trig ratios. It means the same thing. We're going to find the sine, cosine, and tangent from the smallest acute angle. Before we do that, what are we missing in this triangle? A side. How do I find the missing side on a right triangle? The Pythagorean theorem. So we are going to do a squared plus b squared equals c squared. So which one of these is c? 29. Alright, so we would say a is 20, b is x, and c is 29. 20 squared is 400. 29 squared is 841. Subtract 400. X squared equals 441. Take the square root, and x equals 21. So our missing side is 21. 21. All right, so from here we're going to find all of the trig functions, trig ratios from the smallest acute angle. So to figure out the smallest acute angle, what do I need to look for? The smallest side. So what is the smallest side here?
CB.
CB, which is 20. So what angle is across from 20? A. So A is the smallest acute angle. So we're going to find sine from A, cosine from A, and tangent from A. Sine from A, cosine from A, and tangent from A. And we're going to use SOH, CA, TOA. So from A, let's label, what is the hypotenuse in comparison to A? It is 29. Will the hypotenuse ever change? No. What is opposite of angle A? 20. Which means 21 is the adjacent. All right, so sine, would be opposite over hypotenuse. So the opposite is 20 over the hypotenuse, which is, can this be reduced? No. Cosine of A, cosine is adjacent over hypotenuse, so 21 over 29. And then tangent is TOA, so opposite over adjacent, so the opposite is 20 over the adjacent, which is 21. So we're going to circle that. You do need to make sure this is what your quiz is over. Okay? So that was a review of yesterday. Here's what you're going to be doing from today's lesson. This is no different than what we were just doing, but what is the only ratio it wants us to find? Tangent. Does it want sine or cosine? Nah, it wants tangent, and that's it. Okay? So tangent of S and tangent of R, and then write each answer as a fraction and as a decimal rounded to 4 places. So we're just finding tangent of those two angles. So we'll start with tangent from S. Oop, capital S. So tangent is opposite over adjacent. So if we're looking into this triangle from angle S, what is the opposite? 80. And what is the adjacent? 18. Why wasn't it 82? That's the hypotenuse. Good. Go ahead and reduce 80 over 18, which makes 40 over 9. So it wants it as a fraction and as a decimal. So what is 40 over 9 as a decimal? So 4 point, we're going to stop at 4 decimals. So 0.4444. All right, then we're going to do tangent from the other angle, which is R. So from the perspective of R, we need opposite and adjacent. So what is the opposite of R? 18. And the adjacent is 80. Yeah. So we're going to say 18 over 80, opposite over adjacent, which reduces to 9 over 40. All right, and then what is it as a decimal? 0.225. You can put a 0, but you don't need it. So the first 2 homework problems are just like this. First 2 out of 8 or out of 10. All right, go ahead and flip. This is where we apply all that we have learned. Okay? So the sine, cosine, and tangent, here's the purpose of it. What are we missing here? What is x in this picture? a side. So I want you to put that these are missing sides. So at the top, just put these are missing sides. So we're going to find the side lengths. So the first thing that we're going to do is we're going to label the sides from the given angle. So we're going to label the sides from the given angle. So the given angle is the angle they gave us. So in the first problem, what angle do we have? 61. So when we go to label the sides, we're doing it from the perspective of 61 degrees. Okay? So you want to label the two sides they gave us. What kind of side is 22 in comparison to 61? Opposite. And then x is adjacent. So which trig function are we going to use? Tangent, because this whole lesson's over tangent. Okay, so tangents from what angle? 61. So normally we put a letter there, like A, B, C, or D, but that would signify we don't know the measure of the angle, but we do know the measure of this angle. So we're going to put 61 equals the opposite over the adjacent. So the opposite is 22 over the adjacent, which is x. So here's the only issue with this. This is a proportion whether it looks like it or not. What is invisibly under tangent of 61? The number 1. So technically you have one fraction set equal to another fraction. There are many ways to solve this, and there's a very easy way to do it if it is formatted correctly. Here it is not. What we want is the number in the bottom and x in the top. Here's why. What's happening to x if 22 are in the bottom? It's being divided by 22. The opposite dividing by 2 is, you just said it, multiplying by 22. So, do we agree in math, what you do to one side, you have to do to the other? Okay? So if I flip this side, what do I have to do on the left side of the equation? I'm going to flip it. You're not going to flip it every time, but here's what you want. We want the number in the denominator, which means the bottom of the fraction. So we want the number in the bottom of the fraction. So here we kind of had to manipulate it to make it in the bottom. Is everyone okay with what we just did? Okay. If you're in Algebra 2, this is actually called cotangent. It's another trig function. You'll talk about it. Anyways, so we're solving for x. Currently, x is being divided by 22, so the opposite of dividing by 22 is multiplying by 22. So we're going to multiply both sides by 22, and I will teach you how to plug this into your calculator. So you want to pick up your calculator. If you don't have one, make sure you try with the person next to you. So Tony, yours will look a little different than ours. So you're going to type in 22 times. You can do one of two things. If you have the fraction button, which most of you have, so yours might be a little different. If you have the fraction button, you're going to put 1 over tangent of 61. But before you hit enter, you need to make sure of something. You got to close the parenthesis or it's going to tell you error and it's not going to give you an answer. Okay? So close the parenthesis. This is what you should look like if you have a Casio calculator. If you don't have a Casio calculator, you could try 22 times 1 divided by tangent of 61. It's the same thing. Do you have a fraction button? Okay. I'm recording either way, so I'd show them. Okay, so if we type this in our calculator, we are rounding our answer to the nearest tenth. That's 1 decimal place. So what do we get when we round to the nearest tenth? 12.2. So that is the length of that side. 12.2. Didn't you borrow a calculator from me? Okay. Okay. The second problem, we're going to do the same thing. We're going to label the sides from the given angle. So what angle was given to us? Angle 56. All right, so from 56, what kind of side is x? Opposite, and 13 is adjacent. So we're going to say tangent from 56 degrees equals the opposite, which is x over the adjacent, which is 13. So we want the number in the denominator. Do we have to do anything in this problem to make the number in the denominator? No. So you're not going to flip it. You're going to leave it like it is. What's happening to x? It's being divided by 13, so we're going to multiply both sides by 13. Okay, so if you have a Casio, you're just going to type it in as you see it. You could say 13 times tangent of 56. 13 needs to be in the front so you don't make an error. You could also type it in with parentheses here. Same thing. So either way, you're going to get a decimal round to the 10th, and we get 19.3. This is what tomorrow's lesson is over too. We're doing sine and cosine. That's why I said yours is a little different. So I can show you how to do it with your calculator, okay? You kind of have to work backwards. You have to do 61 and then tangent, and then 1 divided by that, and then multiply it times 22. A little backwards. Okay, I'll show you if that didn't make sense. All right, so this is the last thing that'll be on the homework tonight. We're still going to go over something after this, but it's not on the homework. It is a word problem, but they gave you the picture. You are measuring the height of a lamppost. You stand 40 inches from the base of the lamppost. You measure the angle of elevation. So when you think of elevation, you think of like upward, right? So this is the angle opening upward towards the top of the lamppost. It's 70 degrees. Find the height of the lamppost, h, to the nearest inch. So because we're given an angle and a side, we're going to use trig ratios to find our new side. So from 70 degrees, we're going to label the sides. What kind of side is h? Opposite. What kind of side is 40? So which trig function are we going to use? Tangent. So tangent from what angle? 70. Will equal the opposite, which is h, over the adjacent, which is 40. So is the number in the denominator?
Yes.
It is. So we don't have to flip it or anything. We're just going to multiply by 40. Round to the nearest inch. So the nearest whole number is 110 inches. It's a decently tall lamppost. Okay, you're going to flip to the white section, and we're going to do one more thing. Again, this next part, so the white on the back. This next part is not on your homework. Do we understand each other? We have gone over everything that will be on the homework. The reason we're about to do this is so on your quiz is Friday, which is chapel day. This class in particular is really short on Fridays. It's my shortest one. It's like 35 minutes long. So in order to make sure you have enough time, I don't know how much review we're going to get. I have to look over the quiz. So we're doing it a little bit each day instead of just teaching it to you on Thursday and then hoping you get it by Friday. That make sense? So this is not on the homework tonight. Okay? So if you don't understand it at first, it is okay. We are going to eventually understand it. You're going to label this finding the measurement of x. We're going to find the measurement of x. You still need your highlighter out because I'm going to show you something. Finding the measurement of x. And you're going to want to draw the triangle and then write the other 3 problems. Did it say so? I don't know that it helps.
It was like chewy.
It was what? Chewy? Sorry. You didn't let it sit in the back of the Alright, well, it tastes good. Alright, so what is x in this picture? In every single one of these cases? It's a what? It's an angle. So it's not a side. So you're going to do something a little different. You're going to set up very similar, but your calculator work is going to be different. Okay, so you're going to write this down and you're going to highlight it. So whenever you're solving for an angle, you're going to use the inverse. And I will explain what it means, so you'll understand by the end. So whenever you're solving for an angle, you're going to use the inverse. So whenever you're solving for an angle, you're going to use the inverse. I write it on the side, highlight it. You're like, Miss Marshall, I don't even know what an inverse is. You actually use it all the time. Like, if you had an equation 2x equals 8, what's currently happening to x? It's being multiplied times 2. So to solve for x, we would divide by 2. Because guess what? Multiplication and division are called inverses of each other. They undo each other. What's the inverse of addition? Subtraction. What's the inverse of squaring? Square rooting. Weird. So the inverse is what I'm about to show you. Okay? So I will explain why. We're going to solve for the measure of this angle. So we're going to label the sides from this angle. What kind of side is 4? Opposite. What kind of side is 7? Adjacent. So which trig function are we going to use? Tangent. From an angle we don't know. So you could technically name it two things. You could call it x or b. Since we're looking for x, we're going to call it x. So tangent from x, we don't know what x is, will equal, what will my fraction look like? 4 over 7. I'm going to move it over so you can see what we're doing. So here's what happens. What does everything have an invisible exponent of?
1.
A 1. So technically, I know this looks weird. When I took calculus in college, I hated exponents and sine and cosine and tangent. Didn't make sense. Well, it eventually did. But so there's an invisible 1. Tangent to the 1 is what we got going on right here. So the inverse looks like this. In order to get rid of tangent, the inverse is tangent to the negative 1. They will cancel the tangent out. But we know in an equation, what we do to one side, we have to do to the other. So on the other side, we are going to also do tangent to the negative 1. I'm going to move it over so you can kind of see what we're doing. Tangent to negative 1. So here's what happens on the left. Tangent to the negative 1 of tangent cancels out the tangents, and all we're left with is x. And then all you're going to do is type this into your calculator. So you're going to hit shift tangent, and this should pop up. So shift tangent. Once you've got that, you're going to type in 4 divided by 7. You can make it a fraction, you can just say 4 divided by 7, doesn't matter. Then you're going to hit enter. You should get an actual number that looks like a degree. So what do we get? 29.7 degrees. So you just found out that angle x was 29.7 degrees. Okay? You don't have to show this work every time. This is just so you kind of understand what you're doing. Number 2, it says sine of x, which is my angle, I don't know, equals 0.2345. So to get rid of sine, I'm going to do the inverse of sine. And the inverse of sine is sine to the negative 1. So you're going to hit shift sine. Shift sine. Shift sine, and then you're going to type in 0.2345. What do we get rounded to the nearest tenth? 13 point what? 6 degrees. All right, to get rid of cosine, you're going to use the inverse again. So cosine to negative 1 on both sides, even though I don't have room. So shift cosine of 0.8. Has Nate tried these? He did all of them? Okay. What do we get? All right, so round to the tenth. 36.9. All right, and then last, again, you're going to use shift tangent. So what do we get for our angle here? 15 point what? Oh, 18.4 degrees. So again, is this part on your homework? It is not. So you're not going to touch the shift button for your homework. Okay? You're going to take out your textbook and we're going to talk about your homework for a second.